So we're going to talk a little bit about the methane work that we've been doing and about its relationship to feed efficiency, and then will give us a few insights into some of the practicalities around feed efficiency, because I imagine probably there's a bunch of people in the room that have never actually seen the gear working in practice. So we'll go through some of the mechanistics of how it works and some of the challenges. So so some of these slides I've actually taken from, I had to give a talk to the US version of what Richard chairs. There's a global roundtable sustainable beef thing, and they asked me to give a talk to them about what's happening in methane in New Zealand. So some of these slides come from that, but the message is the same, right? So, and this is essentially, even though it's beef, we're making a couple of inferences here from sheep. And in sheep, we know that we can improve, or we already know in beef, we can improve production efficiency using the currently available tools, which includes the feed efficiency measurements. And we also know that we can reduce methane yield by actually measuring methane output and feed intake. And the message here is that they both go together, and I'll get to that in a minute. And the other message is that if we really want to focus on these things, we've got to measure them. And that goes for methane, but it also goes for feed intake. Some of the bigger problems that we've got to solve, and we're still grappling with this even in sheep, let alone, and we're ahead in sheep than we are in beef. Some of the two big problems really is how much emphasis should we put on reducing methane, and why on earth would you do it? And I know methane's a word that sets quite a few people off in our industry, and I get that. And I'm not here to be an evangelist about methane or anything. But the reality is, when you go overseas, as I've had the privilege to do a couple of times in the last couple of years, and you sort of see what's coming, you see how other people are talking and thinking about these things. Actually, what I think about methane is no longer relevant, right? There's 800 million people in Europe that think differently to me, and they're our market, or part of our market anyway. And so we actually do need to put some attention on it. So sustainability and production efficiency, they are essentially two sides of the same coin, or maybe they're similar, not quite the same thing, but highly related. So just going to go through some slides which sort of talk about why I strongly believe that if we're going to get at the methane part of it, we've got to get at the feed intake part of it as well, and the two need to go together. So this is one of those no shit Sherlock sort of slides at this point. So we have some feed, we eat it, and we turn it into production, right? That's what we've done since forever. But now our challenge is that we also eat the same feed, and we produce, well, we don't, the ruminant does, produces methane from eating that same feed. And we want to increase production, but at the same time we want to reduce methane output, and that's somewhat of a challenge to do when both of those two things are driven by the same basic property of eating feed. And then you start thinking about, well, there's some relationships here, and we use some terms. And we often, we've been talking for probably 25 years or more about feed efficiency, and that's basically the relationship between feed intake and production, right? So no surprises there. We've also got the relationship between production and methane, which is generally called methane intensity. So that's the amount of methane emitted per kilogram of production, and it's pretty closely aligned to production efficiency, really, to be honest. And if you did an index that was looking at improving methane intensity, that index would be highly correlated to an index that we'd be selecting for regardless, because actually we're all just trying to improve our animals and make them more efficient in the production sense. So methane intensity gives you a very similar result. The other relationship there is between feed intake and methane production, and that's called methane yield. So that's the amount of methane that gets emitted for every kilogram of grass that the animal eats. And on average, that figure is 22 grams of methane per kilo of dry matter. So we tend to treat it, and the government treats it as that's in terms of our national inventories, that's a fixed number. For every kilo we're eating, we're pretty much putting out 22 grams of methane. But the question is, can we change that figure? So to talk about all of this and to put in a little equation, you'd say, well, if we were looking at methane divided by production, which is a measure of methane intensity, you can actually express that as methane per kilo of feed, which is methane yield. This is high school maths, right? And then kilos times kilos of feed per production, so that's production efficiency. The challenge is that what you want depends on who you are. So we all want feed efficiency or production efficiency. We're pretty keen on methane intensity as well. Our government and our climate agreements, and actually it's not just the climate itself, just wants less methane. Doesn't care how much production we've done. We care, but the climate doesn't. So the challenge here is if we just improve production efficiency, and Andy, you got at this question exactly before in the session that I was in. So if we can improve methane, improve efficiency by 12%, doesn't that just mean that we have another 12% of animals on our farm? And yep, that's the logical response, right? We've got a fixed feed resource. As farmers, we are driven to utilise that feed. It's hardwired into what we do, right? There's a spare kilo of feed around there. Let's look for a ruminant to eat it. And that feed is still going to produce the same 22 grams of methane. So even if we have improved production efficiency and we've improved methane intensity, we actually haven't changed the total amount of methane that we produce. It's just stayed the same, but we've produced more from it. And so hopefully we've made some more profit, but we haven't changed the amount of methane. What will change the total amount of methane is if we can get at changing this methane yield. So if we change that number of 22 grams per kilo of dry matter, if we can make that 18 grams per kilo of dry matter, then all of a sudden we've got the same kilos of dry matter and we've got, I don't know, whatever that is, 10%, 20%, whatever the number is, less methane for the same amount of feed eaten. And we can still do our feed efficiency. We can get as efficient as we want. We can run more animals. But if we change that methane per kilo feed, that's what's really going to keep our climate goals happy. And that's what the government keeps on talking to us about. You can also take that equation and say, well, okay, and this is sort of saying the same thing. Just total methane is equal to the methane yield times the kilograms of feed. So we need to reduce that. So now I'm going to talk a little bit about what we are doing in terms of methane and feed intake in New Zealand cattle breeding, and we really are just getting started. Like the sheep journey started, beef and lamb and others started investing in methane research in 2004, I think it was, so a long time ago, before any of us thought any of this was relevant, and long before a market signal was even halfway apparent. And the genetics part of it probably started a few years after that, and it probably had 10 years of research, and then we worked out that we could start to measure industry flocks, and we're producing EBVs for it now, and we've still got some problems to solve. In cattle, we're starting at that start of the research phase, really, but we know a whole lot more about how to do it. We've got a whole lot more technologies, and we can go a whole lot faster than it took in sheep. So what have we done? So first step that we did was we took 126 heifers, which were from our progeny test based down at Kepler and Pāmu property down at Kepler. and those heifers are either Hereford by Hereford, Angus by Angus, Hereford by Angus, or Angus by Hereford. So they're both way, crosses both ways. That's just the design we're using. It actually helps us estimate hybrid vigour, and so in time we'll be able to estimate the hybrid vigour for methane, but that's not the goal. So we took those heifers in 2023, so 2 years ago. They went for a trip up to Invermay in the middle of winter, and they spent a month or so there, being fed pretty much ad lib baleage, and they were measured twice for methane. They also took some rumen samples and some salivary samples, or you often hear them called buccal samples. They're basically just taking a cheap swab of the saliva, because AgResearch are really keen, and we're keen for them to do this, to develop proxies, sort of measures which give you an indication of methane without actually directly measuring methane. And the results pretty much were, this was the first time animals have been through these cattle chambers. Certainly beef cattle have been through these cattle chambers. I was disappointed I couldn't make it out for the first one because I thought it was going to be a rodeo. But I was proven wrong, and actually it worked really well. The animals behave really well. I guess they probably see humans a little bit more than most because we're measuring a few things on those animals, but not a whole lot. They're not that different from normal commercial or at least stud animals. And the results showed us that the methane measurements were repeatable. So that's the first step, just knowing that you're measuring something, and if you go back and measure it 2 or 3 weeks later, you're going to get roughly the same ranking, right? So you're actually measuring something real. It's not just all measurement error. The next slide is actually a video, if we could play it, which just shows you how these chambers go, and with acknowledgement to AgResearch, you know, they're the key science provider behind this and do all the hard work.
Methane emissions from cattle. This is the first using this system, so we've been measuring methane emissions from sheep for a long time using this particular system. When we measure gases from animals, we use a respiratory chamber which captures all of the gas for a 48-hour period. For breeding, we don't need 48 hours of measures, we just need a short measure. So what we've done is make a simple chamber that basically catches all the gas that's emitted from an animal for just 1 hour, and we monitor that, we measure that, and then we use that to rank animals. It's been successfully done with tens of thousands of sheep. The difference between a sheep chamber and a cattle chamber, obviously firstly is size. We want the cow to feel nice and safe, and we want it to be reasonably narrow, but we have to get the volume of air that we need to measure the gas in the right way. So they're quite tall. The system is built around a really calm atmosphere. Everything's kept very quiet. The animals are loaded very carefully, and we're just trying to keep everything as quiet and as calm as possible. So there are very few tools to mitigate enteric methane emissions on farm. There are very few ways that we can control our emissions. This is giving us a tool, which means that we can actually control or lower methane emissions using genetics, using breeding. So we can measure animals through these chambers, we can then get a breeding value or a worth of each animal, and we can rank them. And the animals that emit less methane per kilo of grass eaten, those are the ones that we're looking for. Those are the ones that we want to breed for the next generation. And because it's heritable, if we choose those animals, then we will lower the methane emissions for generations to come.
Cool. So that's the chambers. In sheep, there's 12 of them. They're on the back of a pretty big trailer, and they get carted around the country. Haven't quite worked out how we're going to do that yet with these cattle-sized chambers, but they are movable rather than portable, you'd say. So step 2, that was all very well. So we knew that we can measure methane, but actually, as I spent quite some time talking about just before, we really want to be able to measure feed intake on these animals. And there's a good scientific justification for it that I've gone through before, but there's also a justification for it that as an industry, that's where the interest is, right? Feed intake and efficiency is something that, to be honest, we are quite a way behind in New Zealand compared to Australia and compared to the US and Canada, and there's reasons for that in terms of our systems. So what we actually said, we knew Te Mania had invested in creating the feed intake facility that they have, and we said, well, how about we move these chambers and put them up at Te Mania, set them up and use them in a commercial situation, which I can't remember who called you, Will, but yeah, there's a bit involved in it. There's a bit of concrete to be poured. I think Will's dad had just found a concrete truck somewhere, so he was keen for a project. I don't know whether that worked out like that or not, but anyway, so with a lot of cooperation and help from Te Mania, we took 4 chambers up there, and we collaborated with Te Mania, but it wasn't just Te Mania. There were 4 Hereford herds that were also doing a feed intake test, and so we said, well, okay, how about we measure methane on your animals, and you can have that data, and we would quite like to be able to use your feed intake data for research purposes, not for production and breeding values or anything like that. And then, so there's 120 Herefords that were there from 4 studs, a couple of whom are here in the room. And then, of course, Will's also putting his own Te Mania stud cattle through there. So there's 360 animals, roughly, that we are getting feed intake and methane measurements on. So basically, we did the methane measurements repeated. We took samples for proxies again, and this time we did the feed intake and the weight measurements at the same time, and developed some data collaboration sharing agreements. So this really is sort of trying to set up the model, because for us to then start doing the R&D to say, well, how heritable is this trait? How much can we really move in terms of methane versus feed intake? Then we're going to need a couple of thousand records. So we're not there yet, but we've started. So this slide is just a photo of AgResearch taking their proxy measures. Those measures are still not cheap. They're probably at the moment about the same cost as a sheep pack measurement, which is about $70. The actual pack measurements for cattle are costing about $400, so they're cheaper than that. But research could well get the price down. So now we're just going to talk. We've got a little video here that Will took the other day, sort of trying to run through a couple of the practical things, and maybe ask a couple of questions about it. So if we could
just a bit of a explanation how the grow safes work. These heifers are just completing the 11-day warm-up period, so they'll start their 49 days of trial tomorrow or Tuesday, I believe. So these have an RFID reader around the rim the whole way around. We fill them up with silage, and they help themselves sitting on load bars. So load bar there and these are wind covers, because they're so sensitive. They're down to the gram on the resolution that the wind can affect them. So they eat away in here. This radio mast sends it back to our office over there. The computer's controlled by a team in Calgary. So each day they check in on the trial and have a look. And then while they're in here, every time they have a drink, it records their front half weight. And in the first week and the last week of the trial, we weigh them through the crush. And there's an algorithm that can convert their live weight to their weight in here. And because we're collecting so many weight points across the 7 weeks of the trial, it means we can cut the trial length down from 70 days to 49. If you don't use the in-pen weighing system, you've got to do 70 days with shoot weights and a crush the whole way through. So that's a really big help. There's dye markers on that too, so we can set EID alerts to any animals that are sick or poor, that aren't having high intakes or they're not eating, if they go off their feed or whatever reason, if they're losing weight, and it'll paint them with a dye, and then we can just walk them out. So that's the grow safes, and got 4 pens through here. So these here are all calves from mixed age cows. They're our first weaning cohort, so they're one contemporary group. They'll be just running 4 mobs for the trial and then put back together. So,
Yeah, so that's the explanation of the practicals. But, Will, I don't know, do you want to just comment, what's the biggest challenge from a logistical point of view that you've faced with these feeders?
Is it going?
Yep.
I'm not sure, sorry. It's easy to underestimate how much feed having 120 animals at a time in there all year round takes. So we're using about 400 tonne of dry matter of silage at the moment in a year. And then just the animals, it's ad lib, they can't ever run out, otherwise you have a failed trial day, and you're only allowed so many failed days in a trial. So to have people every day, twice a day feeding, that's sort of one of the challenges. We were lucky we had an existing resource consent from when that was a quarantine feedlot. So we're consented up to 400 head. So if there's more interest in it, we'll continue to expand it up to that amount and keep doing contract work for other breeders and research groups and things like that. Yeah.
So you just had another research group through there?
Yeah. So with our animals and beef and lambs and the Herefords, with the protocol with Vitali, they can't get above a certain weight, or you want them in a certain age, and then you get to November, everyone's wanting to mate their females, so usually we've shut down over summer. This year we've had Fonterra put in 100 kilo dairy calves, and they're doing work in the background on their cow butcher treatment, and so they're following those animals right through their whole life. And when those animals are a bit older, at some point they'd like them to come back in as well. At the moment, our breaks that we're having a break for biosecurity between cohorts if they're coming from different places. We've got all the pens double fenced, you could see the tapes there. And then we had a few weeks, there was about 4 weeks in February before we weaned that we didn't have animals in there, but yeah.
Cool. I've just got a couple more slides, and then we'll open it up to the audience, and any of you can ask Will all the questions about the practical stuff, and he can take all the theory questions too, Will. So this is the office. I didn't ask you about how far is the office from the actual.
I think it's about 450, 500 metres line of sight. Yeah. Sorry. Also, just a bit of background about how we ended up working with beef and lamb and the Hereford guys. After the trip in 2023, people came, they saw around the world, saw in America and what was happening with net feed intake, and there was a group that were interested that came back, and John was able to coordinate with Matariki, Lime Hills, Okawa and Orari Gorge for them to all send animals up, and then when they came up, I think then we got in touch with you guys, and Jason helped them work out what animals to send so they could work out the most linkages to the progeny test cattle as well. So yeah, that's how that started. So.
Yeah. Now, just in terms of our next steps in this, so for the next 4 years, I was going to talk about this as a hypothetical, but actually we just last week, the New Zealand Agricultural Research Gas Centre Consortium, something like that, NZAGRC, has basically approved in principle, so they're board approved, and we've still got a contract, so there's always little details, but approved us for 3.9 million worth of funding to carry on this work, which is really good news for us. And actually, it's not even leverage funding, right? So there's no direct levy in there. And what we want to do with that is scale up to collect feed intake and methane information on 2,000 plus pedigreed cattle. And our intent is to say we want to part fund intake measurements and fully fund the methane measurements with data sharing agreements in place. So you get to use the data, we do too, for research purposes. And so we haven't worked out all the details yet. We're still working on this, but essentially we'll be putting the offer out there for people with suitable cattle, stud cattle with pedigrees that want to be part of this and work with us together, that we will part fund this, and you'll get the feed intake data that you want. And as was mentioned before, there is only, I think it might have been Andrew mentioned in the smaller session, there's only about 3 facilities in New Zealand at the moment, so definitely we'll be working with Te Mania, and we'll be talking to the other 2 facilities about how we can cooperate with them as well. So that's going to provide the background information that we need to do genetic evaluation of methane and intake in maternal beef cattle. And we really do want to stick to the maternal breeds at this point, because really the big gains from feed efficiency and methane are in the cow herd. And it will initiate the development of a genomic reference population. So genomics is going to have to be the tool that improves, that can spread the information out more widely and help everyone make selection decisions. We're also part of another project that has just been put together and just getting its funding together as well. And that's, and so I should say it's Beef and Lamb and AgResearch that are part of that Cool Beef project. And the 2 organisations plus partners from Australia, USA, UK and Ireland are also involved in this other project called Bluegrass. And that's a collaboration, and it's actually got even some philanthropy, I can never say that word, money in the background of it from places like the Bezos Earth Fund. And their goal is to internationally to help build genomic reference populations for methane and drive the adoption of reduction of methane from ruminants more quickly. It's really important for us from New Zealand to be part of that at this stage, right? So we actually offer quite a bit collectively in New Zealand because we've got a lot of experience, particularly in the sheep part of the game. Going forward, if this becomes long term, we're going to need to continue to collect these really expensive measurements in order to maintain the genomic reference populations and to keep the information current. You can't just stop because after a couple of generations, the genomic reference population is no longer predictive. So you need to keep going. And in sheep, we've pretty much got to carry that load ourselves, right? Because New Zealand sheep are New Zealand sheep and no one else has the same sort of sheep. But in cattle, obviously because we're pretty connected to the Australian and the US population, I think there's a real opportunity there for us if we get on the ground, we can be part of the group that does this, and then we don't have to carry the whole burden of this going forward. So I think it's very timely that we do that and get in early rather than come late to the party and then say, can we join? And what are we compared to the size of what the US will have done? So yeah. So it's a global effort. There's a bunch of companies up there which are all contributing to this in some sort of way. I'm going to finish with one last slide, which is a bit of an advert. So I've been asked to go and talk about methane and stuff to the Beef Improvement Federation in Amarillo, Texas. So anyone who wants to come and watch me speak to a bunch of cattle ranchers who also own oil wells, because they all have these jackdaws on their places, right? Then you're welcome to come and watch. That might be the last you see of me. I don't know. But I did think, well, if I have to go over and do that, then maybe there's a couple of things that we might go and visit beforehand. The bad news is it's in the middle of bull sale season here, so probably most of you won't be able to come. But if there is anyone in the room who wants to join in, and talking with Andrew from Vitali, probably keen to put a bit of a feed efficiency twist on this and join up with maybe even a couple of Aussies. And go and see a couple of places. So, yeah, get in touch. But the caveat is you will have to fund yourself. And the other caveat is I'm not being funded by Beef and Lamb to do... Well, Beef and Lamb don't have to pay my travel money and conference money, right? The Americans are paying that. So just in case you're worried about me doing a junket at your expense, then that's not the case this time. So I'll leave it there, George. And open it up for questions. I'm sure you'll have a lot of good questions of Will, and I'll take the back seat.
Thanks for watching my video too. Jason asked me to do a slideshow. I haven't made one since school. I don't know how, so that was the easiest way.
So I'm looking on Slido. I haven't got any questions yet. We probably have got opportunity for a couple if there's any out there. We've got one, Robert, down the back there, and another one here, and then we'll move on.
I'm not sure if I missed it, Jason, but like with those proxies, are you getting anywhere? Like we did a lot with the sheep, with the rumen and stuff, and as far as I'm aware, there's nothing commercially come out of that. But I agree it'd be fantastic if we could find a proxy.
Yeah, I don't... AgResearch haven't, as far as I know, haven't run them in cattle yet, or if they have run them, I haven't seen the results from them yet, and they'll be waiting till they build up a decent database before they can really do anything. But in sheep, it's looking like the correlation that they were getting between the proxy measurement, which is what the proxy is. They take a rumen sample and then they extract all the DNA in the rumen, and they're basically looking at how that's related to the emissions. And it sort of makes sense because the bugs that are making this methane are in the rumen. So they're doing the rumen DNA. And that is 74%, I think it is, correlated to the actual methane measurements, which is pretty reasonable. So it's quite encouraging. But obviously taking rumen samples is difficult, so the next step is can they do it with just a saliva swab, which is proving a bit more challenging. But I think they'll probably get there.
Another question over here.
Yeah, is there any anywhere where we need to be? You know, you said is it 22 grams? Did you say that?
That's the average.
Yeah. So that's per year.
Well, that's
per
kilo of feed.
Per kilo of dry matter.
Yeah.
Each animal. So where do we need to be? First question. Second question is how is that correlated between some of our like perhaps maternal weights efficiency in our cows as well?
So I can't give you a figure of where we need to be. Probably the answer is as low as possible. So I haven't worked out what we need to do in terms of that target. We actually don't even know, until we've collected the data on cattle, we don't even know how much scope there is to do this, right? We need to be able to estimate heritabilities and correlations. So that's to your second point in terms of your question. Until we've got 2,000 plus records on pedigree cattle that have got all these other measurements on them in the background, we can't do the work to say, well, how closely genetically is this trait related to that one? What we do know is in sheep, the story has been pretty good because basically the methane production has been pretty much neutral to virtually every productive trait there is, which is about as good as you could hope for in terms of an outcome. So there don't seem to be any strong antagonisms there in sheep. Let's hope it's the same in cattle.
Hello, just over here. How did the initial tests go? I know you can't really say too much, but are they above the 22 mark or grams per kilo, or were they looking more promising or worse? Or
I don't. To be honest, I literally do not know. So AgResearch will be analysing the data and looking back at it. And I don't really think about it in terms of that because there's contemporary groups. What I'm more interested in is how much variation there is and whether that variation is repeatable at this stage. So right now, yes, we know it's repeatable. So the measurement actually is measuring something real.
Yeah.
But I can't tell you, sorry, in terms of the 22 grams. It's a good question, though.
Cool. I think I'll wrap it up there as we need to get on to the next thing. But thanks very much to Will and Jason. Great session.
Cool.